Hi there. You know how you sometimes have an idea in your head? Not like an idea, but a lingering suspicion, a theory about something. But you've never had the hard data or the facts to back up your theory or your claim, right? For instance, I live in Chennai, Tamil Nadu, India, and I've always had the lingering suspicion that the traffic is the highest on Thursdays. I have no way to prove it since I have no hard data, but I always had this suspicion. I've had multiple arguments with my friends regarding the same, and I cannot back up my claims because I have no hard data. But with programming, sometimes it's easy for you to prove these things, and in that spirit, today's episode and the next few episodes will try to solve like a real world problem, a traffic issue that I have seen, and I think I have a solution for that. Whether you agree with it or not, I'll leave it to you, but we'll look at it no matter what. All right, welcome back. Wish you a very happy 12,021, or if you're old style, wish you a very happy 2021. You'll notice that Ravi isn't here. Unfortunately, he sprained his ankle playing badminton today in the morning, so he won't be joining us. For those of you who have left comment on the last episode, I really hope you have the calendars should have reached you by now, or at least they're on the way. This is what the calendar looks like. It came out really well, and I hope you like it too. It's clear and everything. I really like it. So that's all I had. That's all I had to show. I really hope you like the calendar. All right. That being said, what was I talking about earlier with the traffic and everything? So let me just switch screens over here, and then we will proceed in just a moment. Okay, I'm going to close this, and I'm going to open a program. I'm going to open a program that I had. Now, this was something that I had written in 2006. Now, this was right after my very first trip to the US, and I couldn't help but notice that the lane systems that they had, that the US had, was definitely contributing to more vehicles. So basically, their traffic system could handle more vehicles per unit of road or per unit of time. So you could have thousands of vehicles move per minute, whereas in India, what I always felt was that the haphazard lane management system that we have, or the lane discipline system that we had, contributed to its slower moving traffic. So I had no way to, but then what would happen in the US is that if traffic stopped for some reason, the entire road would get blocked. Whereas in India, it would still somehow manage to move. So I wanted to sort of see if a lane disciplined versus a lane undisciplined system. Which one of the road systems is better? The red one over here is represents a road system where no lane management happens. Basically, vehicles just try to overtake each other. If they are held up by traffic, they just held up by traffic. I wanted to see which ones would flow faster. Now, this was written in 2006, and it's arguably, it could have been, nowadays we could write it much better. So there's also the green one over here represents a lane managed traffic, and I wanted to see which one flows better. So I have a graph that runs over here, and so the red one, and you can see, okay, so let's look at some few statistics. The number of cars that have passed since the simulation began is much better in the lane managed system. Even though they have like the same number of cars, traffic flows much better, not much better, or more number of cars have passed in the lane managed system. The average speed remains higher in the lane managed system, of course. And if you look at the minimum and the maximum speed, you will see that the minimum speed in the lane managed system is higher than if the lane is not managed. All right. So this was written in 2006, and it was not written in the most optimal way. So I'm going to nevertheless upload this to GitHub, and I'll leave a link to this code in the description of this video. So I'll do all of that. So I wanted to sort of improve upon this, but But what I wanted to do was to show if something that I have always suspected is true or could be true. Let me explain what I mean by that. All right, so now that I have that closed, I have, let me just close the windows that I don't want. All right, so this is what I have in my mind. In the first iteration, or at least in today's episode, we are going to program this road. What is that? We are going to program a traffic system. Let's call it a traffic system instead of just road. All right. It'll have two lanes where vehicles will go, and vehicles will, go in one direction, and it'll, basically travel in the other direction. So this part of the road will always be used to go in this direction, and so in the other. All right. So it has very simple rules. The first rule is that vehicles must avoid each other. I'm not sure if we'll be able to accomplish that, but we'll try our best. So vehicles must always avoid each other, and vehicles must start at a source and end at a destination, which means they'll start at this end of the screen and then they'll end at the other end of the screen. All right. In the iteration 2, or in next week, what we'll do is now that we have built this, and now that we have in the iteration 1, hopefully if we have managed to program vehicles avoiding each other and sort of weaving in and out of traffic, if we manage to program that in iteration 2, what we'll do is we will open up openings, or we will sort of open the road, or we'll open the lanes so that vehicles can now have sources here and the destinations over here at this location. So what will happen is that vehicles will be sort of forced to make a U-turn. So we can have multiple U-turns as well. So in iteration 2, the road system will allow for U-turns. And what I suspect is that this will have the effect of backing traffic up. All right. So because vehicles are always trying to avoid each other, if one vehicle slows down to make a U-turn over here, the traffic will back up at behind it. All right. So that will be iteration 2. In iteration 3, I wanted to replace these U-turns with roundabouts. All right. We all know how roundabouts work, but here is what is supposed to happen. So we'll replace U-turns with just single roundabouts, or as many as we need. And what should happen is that these vehicles should essentially, if, for example, take this green mark, for example, or this green arrow. This vehicle would use the roundabout to get to the other side. If this vehicle was going over here. If this vehicle, for example, was making a U-turn, if it requires to sort of go back where it came from, then it would go around the roundabout and then go over here. The same applies for the traffic that is coming from the other end also. All right. So there is no making a U-turn over here. The only way you can make a U-turn is to go around the roundabout. And I have always had the suspicion that this is a much better way to manage traffic than any other way. All right. This is this is what my suspicion is. That once we have programmed all of this, and once we have all of these running parallel to each other, this system and this system running parallel to each other, I suspect that the traffic over here would flow much better than the traffic in iteration 2. That's what my suspicion is. That's what I want to prove. I cannot achieve this in one episode, so I'm going to sort of split it into multiple episodes. And so today we'll just sort of get started up with the vehicle system. So this is what a vehicle is supposed to look like. We'll just arbitrarily design it like this, with the round bulbous shape being the head of the vehicle and everything. All right. The vehicle will have many properties. It'll have a length. We all know what a length is. We want to have vehicles of many different lengths. All right. Many different lengths, sort of simulating exactly what you see on the road. You see two-wheelers, auto rickshaws, cars, and then you also have buses and everything. They'll also have width and thickness. So the longer they are, or let's just say that the width or the thickness of this vehicle is proportional to the length that they are. So the longer the vehicles are, the more thick they are, or something like that. We'll also program something called as a discipline into each one of these vehicles. So what do I mean by discipline? The intention is that these vehicles would sort of automatically manage themselves on a lane. So the faster in India, I think it is keep left, which means slower vehicles are on the left and faster vehicles are on the right. So on a road, if we imagine that they are separated into lanes, the faster vehicles would always be on the right hand side. That's what I mean. All right. Now the discipline, or we can give it a score. We can give discipline a score of, let's say, 1 to 5. 1 means he has like the lowest discipline. 5 means he has the highest discipline. And what discipline will do is that if a vehicle with the highest has a high discipline, then it will remain on its lane no matter what. So if there is a vehicle that is going ahead of it and it has slowed down, it will still remain in its lane. Whereas if the discipline is low, it means it will start to weave in and out of traffic. That's the intention that I have. All right. There's also this direction, so it knows in what direction it needs to go. So whether it is on the left or on the right, whether it is going on the left road or the right road, that we'll say. And then it will also have something called as a speed. So these are the 5 properties that I have, at least on my, or this is what I basically want to program the vehicles as. So I'll upload all of these documents and I'll make these documents available on the on GitHub. On GitHub. All right. So that being said, as per usual, I'm going to do this in JavaScript, and I have my HTML page ready. I have included the CodeSpace API. I also have a file called as the traffic system. Oh, and another thing, I want to make sure, I want to ensure that I do this in an as object-oriented manner as possible. All right. So this needs to be so each vehicle would be its own object. I'm not sure if the road itself is an object. I'm not sure if it warrants its own object, a road object, but I'm going to have that anyways to get started with today. All right. So yes. So that being said, I have the traffic management system. I have the canvas. I'm calling it V canvas, and I'm giving it a width. The width and the height over here do not matter. Why? I'll let you know. All right. So this is my JavaScript file. I have the width and the height initialized. I also have the context initialized. The canvas context is a pretty big variable name. I'm going to call it V context. All right, for vehicle context, vehicle system context, or something like that. I'm not gonna call it V context. But the most important part over here is that this canvas is going to assume the size of the document itself. All right. So if the screen is bigger, then the road will also become bigger. And let's see what it looks like. So this is what it looks like. I have the console open now. This is my canvas. If I close the canvas and refresh the screen, you will see that it sort of occupies the entire screen. I'm going to leave the console open because I'm pretty sure I'm going to need it. All right. So that's just the setup. Now, where do we begin? All right. So let's begin with drawing the roads on this, on this system. So I have the traffic system.js, and I'm also going to just sort of have another file. I'm going to create another, because this is object oriented. I wanted to sort of keep all of the classes separate in their own JavaScript files and everything. So I'll create a file called road.js. Now, what is road.js supposed to have? Just a class called as the road. So this will be my road class. What does the road class have? One moment before I look up some documentation. All right. So what does my road class have? What do I mean by road? So this system will have 2 roads. One road that goes in this direction and another road that goes in this direction. I shouldn't have closed that. I shouldn't have closed that document. Let me just open it so that we have something to refer by. Yeah, so there you go. So what do I mean by road system? So this is one road. So I'm treating this as one road and this as one road. All right. Each road will occupy the width and the height of this canvas, or whatever canvas width and height you have available. It will basically try and occupy that. Okay. So let's code that in. Let's make it as simple as possible. I'll just have a constructor, and it will so this will give me, I think a road needs to start from an X position. Let's say XX, YY, and I'm also going to have a width and a height. All right, so that will be the width and the height, so as to not confuse it with the global variables width and height. I'm going to avoid calling them width and height. All right, so that being said, say this dot x is equal to xx, this dot y is equal to yy, this dot this dot width is equal to width ww, and the same goes for the height as well. So that is essentially just the road, and it will basically have a start x, a start y, and a width and the height. And I'm also going to create a function called render, and this render will take a context. I'm going to call this some context. All right, so just ctx. So basically this road is responsible for rendering itself. All right, so I'll say context dot fill style. Usually, what is the color of the road? It's some dark gray. It's not black. It's some kind of dark gray. So I'm going to say 555555. We'll see if this works. If it doesn't, we'll just change the color. Context dot begin path. All right, context dot fill rect. Actually, you know what? The correct way to do it is to say rect and then say context dot fill. Context dot fill or context dot stroke. I've been using fill rect for a lot of times. JavaScript just allows it. There are redundant functions all over. That's fine. We'll just use rex. We'll just use rect in this case. Say this dot x, comma this dot y, comma this dot width, and this dot height. That's it, right? So yeah, so that's basically drawn. Now let's create a road and see what happens. Where I'm going to call this left road and right road. All right. So what do I mean by left road and right road? Let's go back to this one. So this would be on the left. I mean, if this was standing straight up, this would be on the left and this would be on the right. That's all it is. Okay. All right. So what is L road? L road is basically new road of, it needs an x and y and width and height. X and y is always 0, 0. Width and height would be the width of the canvas and height. So the left road will only occupy half of the height of the canvas. So that would be height by 2. All right. And I'm also going to say height by 2 minus arbitrarily, I'm going to take a number 3 over here. Why? Because I wanted to leave space for the lanes. Okay. All right. I hope I'm clear about that. Where does the right road start? It starts once again from, not from the top right, but from 0 width, but it starts from height by 2 plus 3, right? I mean, it starts from the other half of the road. It starts from the other half of the canvas. Go to the width, and what will be your height? It will once again, I mean, I can just say height by 2. I don't need the minus 3. So now I have both of those. All right. Next, let me also create a function called function draw system. This will basically draw the entire traffic system. And I'll also create a function called draw roads. All right, which is basically responsible for drawing the roads. What do I do to draw the roads? I'll just say lRoad.render. Remember, we've created this function called render. Just v context and rRoad.render. Once again, just v context. All right, on the draw system essentially calls the draw roads. All right. Why do I need a draw system and then draw roads? Because the draw system is responsible for drawing the roads as well as the vehicles. The vehicles are just not ready yet. All right. At the end of the init function, I'll just call the draw system. Will this work? No, of course not. Because in the index.html, I am not including the road.js. So there you go. So that's the road.js. Now that I have included it, it should work. So there you go. So that's how it is supposed to work. There it is something off. What is off? What's off over here? The reason why I'm saying it's off is because this left road seems to be a little bit bigger than the right road. What am I missing? So just height by 2 minus 3 and start. What happens if I just remove this? You know what? Now it seems even. Should I just leave it like this? Should I just leave it like this? Yes, I'm going to leave it like this. And I also want to make sure that the road is a little bit more darker because that color doesn't seem right. All right, so closer to black. So I'm just going to say 2, 2, 2, 2, 2, 2. All right, yes, now that seems appropriate. Or even 1, 1, 1, 1, 1, 1. Not entirely black, but just like the darkest of gray. I think it represents the road correctly. All right, yes, that's about it. What else do I need? You know what? I'm also going to create something called as a constants. All right, you'll see why in just a moment. So I'll just create a new file and I'm going to call it constants.js. I'm going to create a class called constants. All right. Yes. So how do you create constants? So I basically want this to contain all of the constants that I'm going to need throughout this entire project. All right. So in JavaScript, basically what I want is static variables. In JavaScript, I know one way to do it is to just create like an empty class and then start assigning it like this. So I can say constants dot say direction left is equal to 1. I'm just going to arbitrarily assign numeric values to the left road and the right road. All right, because I think I'm going to be using it very often. Another thing I'll do is so now that we are going to start to create these vehicles, I'm going to start to define the size of the vehicles. I'm just going to have 3 vehicle sizes: small, medium, and large. That's about it. All right. Now I'll say VEH SML is equal to, and I'll just define it as the pixel size. So a small vehicle would be 15 pixels long. A medium vehicle would be, let's say, 25 pixels long, and a large vehicle would be let's say 35 pixels long. All right, that's all. Why am I creating a constants? You'll see in a little bit, because I think I'm going to be needing this class to hold a lot of other constants that I'm going to be using throughout the project. We have the road ready, we have the constants ready. We'll also go ahead and include the constants in our index.html. So now I have the constants ready. Nothing should have changed, no errors, nothing. We are all good. Fantastic. All right, now for the big thing. Now we'll create the vehicle class. Now, this is my vehicle class, and I'm going to have a constructor, of course. Constructor. Now, what are the properties we said we will have? So if you look at the properties, it is supposed to have a length, width, thickness, its discipline, and all of those things. And just for reference, I'm just going to, for now, copy all of this and keep it in my class. I will remove it momentarily. All right. So length. So it would be this dot length is equal to, I expect it to come as parameter. So I'm just going to say size. So this dot length is equal to size. This dot width is equal to, or I'm going to call it thickness, or thickness. I just want to make sure that thickness is proportional to the length. All right. So if it's a small vehicle, it's also proportionally less thicker. Let's also say, discipline. Discipline would be a value between 1 and 5. So I'm expecting this to be passed as parameter. So this dot discipline would be this discipline. All right. I'd also need this direction. What do I mean by direction? It means if it's going in this direction or if it's going in this direction. All right. Why is that necessary? Because if you have speed, for example, the speed has to either, technically speaking, speed is like an absolute value, but in the JavaScript world, speed has to be either incremented or decremented. Incremented because it needs to go from the right to the left, decremented if it needs to go from the left to the right. And I think it will be easier for me to maintain if I say, what is my direction. So I have this dot direction is equal to, so it'll either be direction left or direction right, but then I will leave it as a parameter to this constructor. So I'll just say this dot direction is equal to dir. All right. Now what else? Now it will have like an X and Y and all of those things, right? I mean, it will have an X position and Y position and everything. Okay. All right. So where would that be? It would basically be starting from any position on the screen. I mean, when it starts. So we can just say this is start X and then give also a parameter called start Y. So I'll say this dot X is equal to start X. This dot Y is equal to start Y. So that's my, so that's the vehicle's position. Should I convert this to a point object? Maybe later. For now, I'll just get started with this. Remember that this vehicle should also have, this should be small y. All right, small s. Remember that this vehicle must also have a speed. So I'm going to have a speed parameter. Speed can also be like, say for example, an arbitrary value. All right. So for those, I'm going to create constants dot the minimum speed would be 1, and let's say maximum speed would be, let's say 6. All right. Remember we were also talking about discipline, and so I'm going to create constants dot min discipline is equal to 1 and max discipline is 5. So for now, just for posterity's sake, we'll just declare this and we'll leave it alone. All right. So now that I have speed, I'm going to say this dot ix or increment x would be speed. Okay. Now that this is done, I'm also going to have another variable called original speed is equal to speed. What do I mean by original speed? So basically what's supposed to happen is that when a vehicle is moving, let me just open this, for example, when a vehicle is moving and it meets another vehicle, it will basically just go and stop in front of it. Not stop, but slow down slow down behind it. But if that vehicle changes lanes, or if you decide to change your lanes, you will change your lanes and you need to get back to whatever your original speed was. So you need to sort of maintain original speed, or the speed or the original maximum speed that this vehicle was supposed to travel at. All right. So I have that as well. So I think I have all of the things that I require covered. All right. All of the properties that I require to be covered. Now what? I will have a function called update. What is the update function supposed to do? The update function is supposed to update its X and Y locations. All right. Oh yeah. When you're inside, you don't need. So I'm going to have a function called update. And what will this do? It'll just say this dot X plus is equal to this dot IX. All right. That's about it. It doesn't matter if IX is positive or negative. It would always sort of increment it. It would always sort of increment it. All right. What else do I need? Yeah. Is that it? Okay. So let's create this function called render. What does the render function do? And it will take, let's say, a context as parameter. So I can just say context dot. Oh yeah, you know what? I'm also going to assign it an arbitrary color. Or CLR. All right. So context dot fill style is equal to this dot CLR. Context dot So what else? Context dot begin path. We will start out by making this vehicle sort of just a rectangle, a very simple rectangle. All right. Context dot begin path. Context dot rect. We're going to use this dot x comma this dot y, comma this dot length, which is my width, and then this dot thickness, which is actually speaking my height because it's rendered and then context dot fill. That's about it. It's as simple as that. So now I also have a vehicle, I have the update function, I have the render function. Let's go back to the traffic system and we'll create the vehicles now. But before we do that, we would also need the number of vehicles that are there on this class. And for now, I'm just going to declare it like this. Because we have a constant class, I was thinking that maybe I can just create a constant out of that. But that would mean that if I have to change the number of vehicles just for testing, I'll have to go to that file, change it, and then come back. It seems like a lot of hassle. For now, I'll declare it here. When I finally finish with this, I'll declare it as a constants in the constants class. So the number of vehicles, let's start with, let's say 10 vehicles, and we will have the vehicles array, right? Vehicles is equal to, I'm just going to use the push because I thought I can say new array of number of vehicles and go with that. In fact, let's go with that new array of number of vehicles. All right. So now I have the initialize. I have to initialize the vehicles. So I'll say for variable I is equal to 0, I less than number of vehicles, I plus plus. What else do I need? Yes. Now, what do you require for the vehicle? All right. So I'm just going to copy the constructor just so that I know what parameters to pass for it. All right. So I require a size. I'm going to make the size a completely random thing. All right. So size is like randomly determined. So for that, I'm going to say variable r, which is random, is equal to random between, let's say 1 and 1000. Now, because there are 3 vehicle sizes, I'm just going to check for bounds. I'm going to convert this to an integer so that I have like a proper integer to check with. And if I say, and if this random is greater than or equal to 0, and random is less than 333, 1/3 of the way, yes. Let's have a size variable. Size is constants dot, what was that? Constants dot vehicles small. So I'm going to initialize it as small. All right. So if the random, if random is between these, I'll just leave it at small. Else, if it is greater than 333 and less than 666, which is once again 1/3 of the way, then make this medium. Or else, if it is greater than or equal to 666, just make it a large vehicle. That's it. All right. So now I have the size of the vehicle that I require. Discipline. Remember, discipline is a value between 1 and 5. So that's random between, oh my God, that's the wrong function name. Good thing I caught it right now. All right. So that would be constants dot minimum discipline and maximum discipline. So constants dot maximum discipline. I have that. So I have the discipline sorted out. I should also have the direction, which means it either goes in this direction or it goes in this direction. Aha. Now we have, all right. Yes. Now that I think about it, doesn't matter. Let's figure it out. All right. Direction is equal to, okay. Yeah. I mean, I can just say direction is equal to, left direction. I can just say you are going on the left, which means you are on this side of the road. If I say left, it means it's on the top. Right means it's on the bottom. All right. So direction would be constants dot, by default it's like this. However, if I modulo 2 is equal to 0, which means if it's an even number, then just make sure that the direction is right. All right, so that's the direction right. That's what I want to do. All right, so now we have the direction sorted out. Now we have the start x and then start y. Aha, this is where it gets interesting. All right, if it is going on the left side, if it's going on the left side, I'll have to ensure that it is within the bounds of the left road, correct? So it is somewhere between the width and the height by 2 minus 3, all right? If direction is TIR left, okay, where start x is equal to random between 0 and and width, start y is equal to random between height by 2 minus 3, right? Because that's the top half of the road, because that's the left road. By default, start x and start y are on the left side of the road. If the direction happens to be right, then just make sure that start x and start y are on the other half of the road. That's all I need to do. So start x would still be the same. Yeah, anywhere from 0 to width. Just going to leave it there as of now. And start y would be height by 2. Its height. So height by 2 by height. All right. So yeah, that's about it. I think that should work. I don't have to actually initialize start y over here. All right. Now that we have that, let's also create the speed right here itself. Now we have the start x and the start y figured out. Now let's do the speed. All right. We can do the speed here itself. We can say speed is equal to random between what's that? Constants dot TIR. Constant, not TIR. Min speed and constants dot max speed. So I have the minimum speed and the maximum speed. So that, it will give me a random number between that. If it is on the right hand side, just make sure that it is multiplied by -1. Why -1? Because I need it to go the other way around. That's all. So I'm just negating that. All right. So now I have all of the variables in place. All I have to do is create the vehicle. So I can say vehicle, or I can say vehicles of I is equal to new vehicle of, what do I need? Size. What's my size? SZ. That's my size. What's the next one? Discipline. I already have a discipline, which is great. And then what do I have? I have direction. So there you go. So that's my direction. Then what do I have? I have the start x, start y. Then I have the speed. Oh, I need a color. I did not initialize the color. So once again, let me just create the color as well. Red is equal to random between 0 and 255. This will return me a decimal value. So I'm going to convert it back into an integer. Parse int. Going to do the same for green as well as blue. All right. Now that I have that RGB, say color is equal to, just like last week, where we created the color using the 2hex function. 2hex. The same with RGB. So RGB. So now I have the color, so I can just pass this color over here. Now that I think about it, if I give a random value between 0 and 255, there is a possibility that all these three values are closer to 0 than they are 255. So it might become a very dark vehicle. So I'm just going to say 75 over here. That's all. All right, so that's perfect. So now, so that's RGB. I have the color and everything. So yeah, so that's it. What do I need? Let's see and render these. So I have the draw roads. I'm also going to have a function called draw vehicles where I use the same for loop. Right, just going to copy this. All right, vehicles of I dot render of what is my context called? V context. Yes, that's it. I think that's it. All right, and then I call the draw vehicle. So the draw roads has to be first, and then the vehicles has to be drawn because the vehicles appear on top of the road. All right, yes. I have no idea why that was funny for me. Of course, dir right is not defined on init. So that's at 67. It says. Oh yeah. Vehicle is not defined. Haha. You know what? I probably have not included it. Yes, of course I have not. So I'm going to go ahead and now include it. Vehicle.js. There you go. That's what my vehicles look like. All right. They're just little rectangles. Maybe I should make the sizes a little bit bigger. Yeah, let's do that. Let's make the sizes a little bit bigger. Now that I have these constants, the small one is 25, 35, and 45. All right, now it makes a little bit more sense. They're not updating anything yet. Why not? Because we are not updating it. Yeah, because we are not updating it. All right, so now that I have the init, I'm also going to have animate, which will basically do the animation, right? And what do I need? What do I need for this animation? For now, all I need for this animation is for the vehicles to basically just update themselves. All right. So remember, we are calling this update function, which on this one would just increment the value of the vehicle, or would basically, start moving the vehicle. That's it. And I'm going to say request animation frame of animate, which has the effect of calling the animate function back again as soon, right after the frame is available for drawing. All right. So once I have the animate, once I do the update, I have to call the draw system function from over here, and then it will basically draw everything. And over here, I should not call the draw system. I should call the animate, which will basically animate the entire thing. All right, so there you go. So that's the direction right and the direction left. There is absolutely no collision detection happening. The vehicles are absolutely not avoiding each other. And also they don't look like vehicles, because remember, this is what I had in mind. So that, I have like a proper circle going on over here. All right, so you can at least see that that's the head of the vehicle. All right, how do I do that? It's pretty simple. Let me just go back to my vehicle class. So right now we're just basically, doing this begin path rect, just drawing the rectangle. I'll just put a circle right in front of them. That's all they ever are. All right. So context dot begin path. It's the same fill style. I don't have to change anything on the fill style. I'll say arc. Where do I draw the arc? I'll say this dot x comma. Say this dot y. For now, I'll start and what should be the radius? Ideally speaking, the radius should be the thickness of this vehicle. All right. So I'm just going to say this dot thickness. All right. Is the thickness the diameter or is it the radius? I think it's the diameter. I'm just going to say thickness by 2. Start angle is 0. End angle is math.pi into 2. You know what? That's a calculation that needs to happen for every vehicle in the system and for every time the system is drawn. So here we go. I'm going to create a constant called 2pi, which is nothing but math.pi into 2, so that it is pre-calculated for me. All right, so I can just use this pre-calculated thing and just assign it over here. What else do I need? Anti-clockwise or clockwise? I'm just going to set it as true. All right, I am hoping that this works. Let's see what happens. I see no circle anywhere. What happens? Oh yeah, of course you don't, because I have never said context.fill anywhere. All right, so there you go. So that's entirely the wrong thing to happen. Okay, so what should happen? The y over here should be a little bit offset. Offset by how much? Thickness by 2. So I'm going to say plus thickness by 2. Okay. Oh wow, this side of the vehicles look correct because they are indeed moving in the correct direction, but the other ones, they're not moving correctly. Why? Because they're moving because they're on the left side of the road. They're moving right essentially. All right, so this is correct. It's correct for the right side of the road, but it's not correct for the left side of the road. So we need to fix that. Fix that how? So I'm just going to say if if this dot direction is equal to sorry about that, constants dot dir underscore right. Yeah, so now so let's just see if this works properly. Yes, this still works. I just have to worry about the other one. Else, if it is on the left hand side, I'll basically do the same thing. Oh wait, why am I doing so many? I can begin path and then just draw the arc once and then fill the arc over here so that I can basically avoid repetition of code. So there you go. Where should the x of this one be? It should be plus. If it is on the left side, it should be this plus length. I think so. There you go. So now they properly look like vehicles. All right. Another thing I've noticed, one of those vehicles was very close to the edge. I did not want him over there. I really did not want him over there. So when I go back over here, remember I was choosing their start X and start Y somewhere. I'm going to make sure that their start X is not, I'm just going to say -10 or let's say -5 for instance. So random between height by 5 so that they avoid, what's this? Why is this on 0 to height -2? Yeah, see, they're right on the line, which is not correct, right? Which isn't correct. So I'm just going to say -10 over here, and hopefully none of them. All right. I'm refreshing the screen over and over again because obviously what I have not done is to ensure that they loop around. All right. I think I'm happy with that. All right. And the same goes for this guy also. Don't appear too much on the so just don't go too off screen is what I want him to do. And I also want to make sure that these guys don't touch this line or the divider line, except if when they want to make a turn. All right. So so now so we are getting somewhere with this. All right, we're getting somewhere with this. What I want to end this episode with is I want to make sure that these vehicles basically loop around. So they go off screen and then they end up on the other side of the screen. That's where I want to end it. I think that would already be like a 1-hour episode. All right, so let's see. So now that we have the number of vehicles going on, I have the animate function, the animate, which basically does an update and then it does the draw system. So where do I check if they have gone out of bounds? All right, so I am going to, so here's the idea that I have. All right, when the vehicles go off screen, it is not the vehicle that is responsible for reinitializing it back to this to square one, or basically to the beginning, but it is the traffic system that is responsible for animating it to the beginning of the screen. So that's what I'm going to do. So I'm going to create a function called check bound or check vehicle bounds. All right, what is it going to do? And it's going to take a vehicle as parameter. going to take this vehicle as parameter, or a vehicle as parameter. Now I'm going to say if a vehicle dot x, all right. So if it's x, I really hope I called it x. I didn't call it anything else. Yeah. So yes. So if this vehicle, if a vehicle dot x is greater than, oh hold on, it can either be greater than width by the width, or it can be less than 0. All right. So which is great. So if I, this is why I'm great. I'm glad that we had that direction variable declared over here. So if it is moving, if it's on the left side of the road, dot direction is equal to constants dot direction left. If it is on the left side of the road, then check if the vehicle is greater than the width of the canvas, width plus 40. Why am I doing plus 40? Because I wanted to go a little bit beyond the canvas's width and then only initialize it. All right. So now if it is gone on over here, then initialize it. Initialize it how? I'm basically just going to create a whole new vehicle altogether. So or should I, yeah, I'm just going to take an index, for example. I'm not going to take a vehicle because I think it will be difficult for me. No, let's just go ahead and try it. Let's just go ahead and try it. I'll let you know what I meant by that in just a second. I'm going to remove this comment. All right. Does it have, okay, yep. So I'm just going to copy all of this. Should probably avoid repetition of code. I'll tell you what I mean by that. All right. So now I'm just going to reinitialize it all over again. So I have the minimum and the maximum discipline. Oh yeah, I don't need this. If a vehicle starts in a specific direction, it remains at that specific direction. All right. So I'm not going to initialize the direction. Oh, instead what I'll do is I'll just say vehicle dot direction. I'm not going to do anything over there because it loops around its own road, but with new values altogether. So once it does that, I have a new color, and then I can just say a vehicle is equal to new vehicle with all of the new values, except its start x and its start y are not random values. They will be off screen. What do I mean by off screen? If it is on the left side of the screen, it means it has to start somewhere off screen. I'm going to make this 50 just in case. I mean, I'm making it 50 because I know that the minimum vehicle size is at least 45. So I wanted to go at least off the screen somewhat off the screen before I start to initialize them. All right. So SX would not be this. It would instead be, let's say, minus 50, so that you start a little bit off screen and then you have a random Y location, of course. And I do not need any of this. Yes, I do not need any of this. Do I need this? All right. For now, I'm going to leave it like this. Now, I'm going to repeat the same thing for the right side of the road. All right. Else, if a vehicle is equal to PIR underscore right, if you're on the right side of the screen, and if X is less than minus 50, only then initialize it to one of these values. So discipline would once again be a random value, direction would remain the same, and you would start off screen with plus 50. Why am I choosing 50? Arbitrarily. All right. And then I have a new this thing, and that's it. All right. So I now have a lot of repetition of code is happening over here, but let's not worry about it in this episode or over here. So now I have this, and then I'll just say vehicles of I. Check vehicle bounds. So do the update, but check vehicle bounds and then pass the vehicle object over here. So hopefully they should just loop around. All right. So they are all gone off screen. I am not sure what is happening to them. Just going to refresh it once again. All right. So if it is on the right side of the screen, I'm just going to check its X position. Hey, this function isn't even being called anywhere. So that's the animate, which does the update, and then the check vehicle bounce. Is it dir or, oh my god, it's direction. I have no idea why I thought it was just dir. That's why it wasn't returning anything. I'm going to remove the constants. I'm sorry, the console.log. Yeah. So now let's see what happens. Still nothing. Should have probably just left the console log. So just for the left vehicle. Has it gone beyond the screen? It has. So it has gone beyond the screen. So why is it not initializing? You know what? I think this whole vehicle thing, it doesn't work like that. It doesn't work like that. I think it's because it's passed by, not by reference, but by value. That's what I'm suspecting is happening here. I'm going to remove this. And instead of passing a vehicle, I'm going to say pass an index. So I'm just going to say index so that I can say something like vehicles.index of direction, so that I can check its, so that I use the indexes over here. All right. So on that specific index, it would be, all right. Cannot read property direction of undefined at check vehicle bounce. Oh, yeah, of course. I have to pass I, not vehicles of I. Now let's see. There you go. So that's basically looping around. So that's basically looping around on the left side of the road. It loops around, but on the right side, oh wait, they have looped and then they have vanished. So they do that, and then what happens to them? Am I doing something with the direction? No, nothing. So I just have small, large, random between a new discipline, and then all right, just going to do a console log over here. Just going to do a console log over here, and let's see what happens on the direction on the right side of the road. So they do go over here, and they must initialize. They do get initialized because the console.log happens only once. Alrighty. So yes. So what happens after that? So they do get initialized to something else. Oh yeah. You know what happens? So I think because I make them with plus 50, something does happen to them. All right. So we'll try to figure this out. Okay, just putting a little bit of. JavaScript is very, very forgiving with missing semicolons and everything. Yeah, but just for completion's sake, I'm just adding them while I try to think about what am I doing wrong here. Why is it not initializing it where I need it to? Just going to look up some documentation with arrays here. All right. There's probably a lot of dead air that's happening here. So that's my speed, which is minimum. I know what's happening. So speed should be Yes, if it's on the left side of the road, it's positive. If it's on the right side of the road, it's negative. So it is whatever random into -1. There you go. So that's, I think that was one part of the puzzle that was missing. Let's see. All right. So they should essentially initialize. Oh, why are they on the top? You know what? Yeah, of course, because I just copied the code. I didn't bother to, because I just copied the code, right? So SY should be this. So if you are on the right side of the road, you should be this. Should be this. If you are on the left side of the road, you should be this. Correct. SY should be this. Yeah. I think now we should see it properly looping around all the time. Why are these going the other way around? Okay. All right. I'm going to remove the console.log. Okay. And they only seem to be sort of looping around only once. Oh no, they are looping around multiple times. Looping around is not an issue anymore. Why are they gone completely off screen? Why are they gone completely off screen? All right, let's try and figure it out. Let's try and figure this out. You know, I hate it when everything works, but it doesn't work right. So I have this. So yeah. So what happens the second time around? So what happens when they come around the second time? Because what seems to be happening. Let's try and figure this out. So I have this. So they go here. Are these vehicles getting initialized on this side of the road? No. No, they're not. And then they disappear completely. All right. So I'm going to have just 2 vehicles. All right. So they should be on the either side of the road, and I'm going to console log their positions so that it's all right. So that got initialized, and then this guy got initialized. I'm going to console log this so that it's easier for me to figure out what is happening. All right. All right. Let's see. All right. So I just have these 2 vehicles. So they do go around. Oh, and okay. You know what? I'm going to have just 1 vehicle. You know, good thing I declared it like this so that it's easier for me to read the values. All right. Let's see. So he just keeps going. I'm going to do a parse int at the console log. All right. So he goes beyond the screen, gets initialized back over here, keeps decrementing, and then he just keeps going. Why? Why does he do that? Am I not assigning the direction correctly? Yeah, I mean, if it's on the left, just make sure that you are on the left. That's all. All right. Instead of doing it the other way, let's do it this way. And if you're on the right, just make sure that your direction is right. Right? I mean, if you're on the right side of the road, that is. All right, so there you go. So he keeps on reducing and then comes back around. So you can see it coming back around. There you go. I think we fixed that. I think that something was off with that direction variable that we were assigning, which is why it was not working correctly. So I think we have basically successfully debugged this issue. So I'm going to set it back to 20 vehicles as it was. I'm also going to remove the console log, comment it in this case, and let's see how this works now. So there should now be a continuous stream of vehicles just flowing on the screen. That's all. That's all I wanted to do as part of this episode. In the next episode, we will give them something called as the pathfinding algorithm. And we'll also make sure that they follow lanes. All right. And that's where the discipline will start to come in. All right. And what do I mean by that? I just want to make sure that, if they are highly disciplined, they stay on their side of their lane. If they are not, they go on the other, they sort of switch lanes and everything. We'll also try to sort of clean up a lot of act over here. But I think for this episode, we are essentially, complete. Say control 1. So that's all I had for this episode. Thank you so much for joining. Thank you so much for joining this week's episode. I really hope you like the calendar that was sent to you. This is the 12,021 calendar that I shipped to some of you. I still have to give to some of you, people who have commented on the last episode. It came out really well. I hope you like it. So that's all I had. So from myself, Ravi, and from CodeSpace, wish you a very happy new year, and thank you for joining this episode.